So AWS, and I have the same logo that's on the stickers that they so graciously gave us.
Nice.
Give Bob a couple
yeah,
too, come on.
that's annoying.
Amazon Web Services is a whole, now as of January of this year, there's about 40 individual services that they offer that are on this platform. Some of them are at the computing level, which is like EC2, and I'll go into a description of what each of these are. EC2, Elastic MapReduce. Some of them are application level, like they have a simple notification service, they have a workflow service, and then some of them are more storage. S3 is storage. They have RDS, which is a managed database service. They had Redshift, which I believe Redshift is a sort of database service where you can stream data or something like that. They have a lot of services. I've only touched a very small number of them in what my usage was, so it's not like I have a lot of experience with all of them, but some of them are very specific into what they accomplish. So whenever you hear cloud computing and things like that, most companies, or there's a lot of large companies that they use AWS as their whole underlying infrastructure, even though you may not know it. The positive side of AWS is, so they offer both Linux machines in EC2, which are virtualized servers, or Windows machines. I can look into, I have a slide, we'll look at the pricing of what the pricing of the individual services are. But with a Linux instance that you start up, I timed it was about 1 minute and 20 seconds, 1 minute and 30 seconds, from the point in which I hit the run button to the point where I can actually remote into the machine. So I mean, in 1.5 minutes, I had a whole machine stood up, a brand new server basically, where I can go in, install whatever I wanted. You have full access to the machine, you have root access. It goes along with that, you have to make sure you secure these instances because out of the gate they're opened up to the world. They do a couple things that secures them out of the gate, but EC2 is their most largest used service, which stands for Elastic Compute Cloud. And that is Linux servers, Windows servers that they spin up. So yeah, I said there's 40 services. This is, so the Amazon Web Services are split up into 2 levels of chunks basically. The highest level are called geographic regions. And there's actually 10 geographic regions that Amazon hosts. And you can see from here, the largest geographic region that is used is the US East region, which is based out of North Virginia. The US East region hosts the majority, nobody has exact statistics, but the majority of the EC2 instances are housed in the US East region. The ones that I'm spinning up here today are all in North Virginia. At ACI, where I work, we have a data center in US West, Oregon, and then we have another data center in US East. Now, to combat that, to minimize outages, what Amazon has done is, this is where you get into what they call availability zones. In each of these regions, there's multiple availability zones. So what they've done is they've segmented a set of data centers into a region. So US East, I believe, is 4 or 5 data centers. And each of those data centers is called an availability zone. So when you spin up a machine and you start a machine, it's placed in one availability zone. And when I get to that point, you'll see from the identifier of the machine, the last part is like 1A, 1B, 1C, 1D. That identifies the availability zone you're in. So if something happens in that one availability zone, in data center 1 of the East region, if you're using RDS, if you're using EC2, they'll actually transfer your machines and your data to another availability zone within that geographic region. So that's how they get around downtime. So if they have one data center go down, depending on the services you're using, you will not have a full outage. They will transition those resources to another availability zone. And there's stipulations that, like I said, there's certain services that you can't do. They call it multi-AZ deployment, which is multiple availability zone deployment. Their hosted database service by default uses multiple availability zones. So we have an iPhone app, and the server portion of the iPhone app runs MySQL on AWS in the relational database service. That we have failover in multiple availability zones. and I believe our IT guy set it up so that if something ever happens in the US East region, that will transfer over that database, the data will transfer to the Oregon region. And then we have set up DNS failover for that. So that's another trick. If you can't transfer machines, if you create two matching environments in two regions and then you move the data from one region to another, then you can use DNS tricks to say, okay, everybody that went to this website, now it's pointed at the Western region. So all the traffic will be routed there instead of Eastern region. So you can also do some tricks here to minimize outages on your data centers that are deployed in this infrastructure. I think there's 10 regions and something like 25 or 30 availability zones within all those regions. So worldwide they have about 30 data centers, 10 geographic regions that they segment all of their managed services into. So it's a lot of infrastructure. Estimates, nobody has an exact figure, but I believe it was 2013, they estimated that the income that Amazon was making off of their Amazon Web Services was approaching the $2 billion range per year. So they make a lot of money off of this service. There's no way for anybody to tell.
Say that again, how much?
Somewhere in the range of $2 billion in revenue per year.
And how old is this service now?
So they first launched it, I want to say it was 2006, 2005.
Sounds right.
So it's been out for a little over 5 years it's been out now. When they first launched in 2006, they had a fairly large outage. Just recently, and this is in the last month, they sent out notices to everybody, but they were only certain sizes of machines. They said, we have to reboot all the machines in this specific region, or in all regions, machines of these sizes we need to reboot. Your machine will be rebooted within the next 3 days, and we can't tell you when your machine's going to reboot, it's just going to be rebooted. Because they had a vulnerability that they detected before it was publicly known on the internet, and they patched it and they needed to restart all the machines to apply the patch. So a lot of people were up, a little bit ticked off about that because they wouldn't tell anybody when their machine was going to be rebooted. They just said, in the next 48 hours, your machine's going to be rebooted. So, and that was for a vulnerability that just came out related to Bash, which is the Bash shell for Linux. And it was a pretty large one. So they had to patch all their machines and restart all the machines. So I think you had some of these images on your slide. So I only had, I didn't dig into exactly how all of these companies are using it. I think on the next slide, no. On a later slide, I had statistics about Netflix, and it's pretty amazing how much Netflix relies on AWS for their streaming service. If anybody used Reddit at the bottom here, right about there, there was, Reddit is like a social news site where people can go and post news stories and comment on it and such. And last year, they have a section of Reddit called Ask Me Anything, where people will go and say, hey, I'm this person, ask me anything, and people will post comments and that person will reply. They're on the phone with somebody at Reddit and they're fielding their questions. Last year they had President Obama that did one of those. And they knew 2 days ahead of time that he was going to do this AMA. So because they knew that Obama was coming, the site was going to undergo a huge amount of traffic. Out of the gate, Reddit uses AWS. They use EC2. And they serve up static content from S3, which is a storage area that I'll show you. So what they did was, prior to Obama's AMA starting, they started 30 additional EC2 servers to take the load. Immediately after the AMA started with President Obama, the site quickly was saturated with traffic. They started an additional 30 machines in under 10 minutes. So just for that one AMA, they started 60 additional servers to take the processing load of the traffic that was being hit the site. And then after the AMA was over with, they just turned off those 60 servers. So in the period of about 10 minutes, they started, basically tripled their infrastructure, served up all the requests for Obama's AMA, and then spun down the infrastructure. And I think it lasted an hour or 2 hours. He actually did the AMA on the site for it, which is pretty amazing. Reddit also uses another service called Elastic MapReduce, and they use that to analyze traffic patterns on the Reddit site. So they'll use that and they'll crunch that and turn it into different data sets that they can use for analyzing data that they gather from the site. There was another one that I think I have a shortcut to it here. This is, so there's, where was it? There's, Amazon also produces, in their storage service, they have these data sets. They're free data sets that you can download, and they can sync it to your S3 bucket, which is a storage service. And this one was kind of interesting because I was looking at web crawlers and how people are using Amazon to use web crawlers. And I found this nonprofit organization, what they do is, it's called Common Crawl. What they've done is over the years, they've indexed 5 billion web pages, and they've gathered 541 terabytes of data. And this 541 terabytes is stored in Amazon's S3 service. And if you want to look at this data or analyze it, they provide a client. You just go and you pull this data into an S3 bucket, and then you can do whatever you want with it. You can send it through the MapReduce service if you want to look for certain words or figure out how many pages contain the word sale. And that's kind of interesting. There's a couple other interesting data sets on here. If you go to the root of data sets, you can snoop through them. There's a whole bunch related to biotechnology. There's Google Books. They have a whole bunch of information about books that they store in S3. NASA has data sets in S3 that's publicly available. So this is kind of interesting to look through if you ever want to play with some free data. This is all free, and it's various sizes. I think the other one I looked at was the million song data set. So this is a data set of 1 million songs, and that's 500 gigabytes, so that's not too large. You could probably download that on your machine. And there's instructions how to get these data sets and what you can do with them and things like that. So that's kind of interesting that people amass this data and then dump it in Amazon's service, which is S3. And I'll show you that one. So I think the next one, so this brings to the commonly used services. There's, like I said, there's 40 services in total. I haven't used anywhere near that many that Amazon makes available to you. But these are the most common ones that people will use in AWS. EC2, which stands for Elastic Compute Cloud, is the virtualized servers that you can start and stop in AWS. They kind of call it another service, but it's really a part of EC2, which is called Elastic Block Store, the EBS. All EBS is when you start one of those servers and you want to attach an additional drive. That's what EBS is. EBS is just another logical drive, like if you had a D drive or an E drive or an external drive that you plugged in, it just shows up as an additional drive. And when you create that volume, you say, I want this volume to be 10 gigabytes. And then you could say, attach this volume to this server, and then it shows up on that server as, you know, the D drive or E drive, and you can store data on it. S3 stands for Simple Storage Service. Like my last presentation, all of these, another thing to add is all of these services all have REST interfaces in front of them. So you can automate all of these services. They have a web page that I'll show you that you can go and you can do all of this from a web page. But all of these are programmatically accessible via REST APIs. So if you wanted, for instance, S3 on our iPhone app that we have, it's for appraisers. They would take photos of a property. They want to upload it and pull it down into their desktop software. When they upload it, we take those photos and we push them to S3 buckets. And then when they get back to their desktop, we pull those down from S3 storage. So S3, it's like a drive that you would have. The only difference is that it's not logically attached to one of those servers. It's more just another set of files that you have hanging out there. You can put backups in it. If you take snapshots of the machines, AWS will automatically put it in an S3 bucket for you. I have a demo here of a CloudFormation script. When you create a CloudFormation script, it dumps it into S3 for you. The cool part about S3 is Amazon states that it is unlimited storage. Each bucket that you can create can hold an unlimited amount of objects. The statistic I had, and I think it was on another slide, as of January of this year, there's been all of the S3 buckets. So you have an S3 bucket that you create, and in that is the objects, which is like a picture, a file. Across all of AWS, there is now 2 trillion objects in the Simple Storage Service. So that gives you kind of a scale of how much stuff is stored in there. But it's interesting because they say there's no upper limit to how many objects you can place in a bucket. We have another service that we crunch FEMA flood data, and we sell that back to the appraisers. And in that, we take a daily snapshot of, okay, here's this map that this person pulled, so we can look at those and figure out where our gaps are and help fill those gaps. And we have all those dumped to an S3 bucket, and it's kind of frustrating because you scroll through the S3 bucket, and without having metadata on these objects, you can't really find the one you're looking for.
Right.
So you have to, they can do 650,000 S3 requests per second. That means every second there's over 500,000 requests coming in and out of S3, which is pretty interesting. It's a lot of data. 2 trillion objects stored in S3. Every single day, a third of internet users touch some level of AWS infrastructure, whether you know it or not. That's 30% of the global internet users. Every day, Netflix accounts for 1/3 of all Amazon Web Services traffic at the peak time. So that's probably like 6 to 9 p.m. when everybody's streaming Netflix. They chew up 1/3 of all of AWS traffic, which is massive. It's a lot of data being pushed around. The other service I mentioned, which is Elastic MapReduce. Under the covers, that's a Hadoop cluster. In January 2014, Amazon stated that they have launched 5.5 million Hadoop clusters to crunch data and analyze data and produce analytics. And I had a sample I spun up by having an S3 bucket I ran. They actually have it's called a word counter sample you can run in MapReduce. And it takes, I think, content from books, and it'll count how many times a word occurs in each of these books. And then it pulls that into one data set, one file that you can just look through and say, oh, that word showed up 3,526 times. It's pretty interesting. I have 2 different scenarios I'll run through here. It takes 1.5 minutes to start the machine, and then probably less than 10 minutes to set up WordPress, install MySQL, have a blog set up, and on a full machine, have your domain pointed to it. It's just amazing how quickly you can start up a machine in this infrastructure. It's lower cost that you're going to end up paying than putting a bunch of servers in your rack at your office. At ACI, what we started to look at was started to look at the amount of money that we were paying for hosting hardware in our data center here in our data center in Jacksonville, and quickly realized, okay, if it's going to cost us this much a month out of AWS, and we don't have to pay for the batteries, and we don't have to pay for the new virtual server we're going to have to spin up to host these next 20 machines we're going to need, and instead we can run them in here for pennies on the hour. Let's see if we have a scalability aspect of moving everything to this type of cloud infrastructure. That leads into you don't have to manage the hardware. You don't have to worry about it breaking down or installing new memory. A good example was a couple months ago we had one of our servers was under heavy load, and it was a Windows Server 2012 that was hosting an ArcGIS server, which is for geographical queries. And we saw that it was a little bit starved for memory. Now normally we would have to shut down the machine in our data center, go get the more memory, pop it in the machine, start it up, make sure that was regular. Since we hosted that machine in AWS, we went into the AWS management console and said, okay, add 4 gigs, I think it was, we added another 4 gigs or 8 gigs of RAM to this machine, and you click a button, we didn't even have to turn off the machine. It just instantly popped up, and the machine started to run with that additional hardware. So it's pretty amazing that you can just say, okay, add more firepower to this machine, which that scenario would be scale up rather than scale out, but hey, here's more CPU, and in another scenario we added more, we moved the machine up in its sizes, and I'll show you the machine sizes that they have available. So we said, okay, this one's a medium-sized machine, we want to make it a large machine. And you can do that on the fly, and it'll add additional CPUs and additional memory to the machine on the fly. And the last part is Amazon says you pay in this infrastructure, you pay only for what you use. So if you have a machine, like I have right here in EC2, right now I have these 2 machines, and they're stopped, they're not running. So right now I am not paying for those machines. It's not costing me anything. Only the time in which you're running the machines is what you're actually paying for. I skipped some setup steps here because part of communicating with these services, you have to generate basically a SSH key, and that allows you to communicate with all the servers that you start up in EC2. So the only step I've done at this point is when you go in, yes please, when you go in and you initially set up, thank you, when you set up your AWS account, they will say you need to generate SSH key, and they'll allow you to download that private key one time, and then they delete it from their servers. Without that private key, if you have machines running, you can never get to that machine again. There's no way you can access it, and that's for security purposes. They don't store those private keys, they just validate that when you're coming in that the encrypted key is the same against whatever the public key is that you and them both share. In this account, you can create, AMIs stand for Amazon Machine Image. So the way that this works is just like with a virtual server. You create a server and you take a snapshot of it, which is like a picture of that server. And then what Amazon does is you do all this from their platform, and they have these community AMIs available. So right here you can see there's an Amazon Linux AMI, there's a Microsoft Windows Server 2012. There is literally thousands and thousands of these images that Amazon gives to you that you can just launch off of. What we do at ACI, since we have very specific configuration around our Windows Server 2008, Windows Server 2012 installations, we start with one of their images, we customize it, we lock it down, we may install some antivirus, some intrusion detection security tools, and then we create an AMI from that. And then we'll use that as our template, so anytime we need a new server, like if we need a database server, we'll grab one of their AMIs that has SQL Server installed, and we'll take a snapshot of it. And then anytime we need a new SQL Server, we'll just spin it up off of our image that's pre-configured for whatever we need. If we need to update virus definitions, or we forgot to set the view options on Windows, which is a pain if you don't set it, you have to create a new machine off of that image, change your options, delete the old machine image, create a new one, and now you have a new snapshot that you can work off of. But for the purpose of this, they have a quick start, and you'll notice that some of these say free tier eligible, and I'll go into the price, and when we look at the pricing, Amazon has this whole free tier. So you can basically, you sign up for an account, you can use a whole bunch of services for free for an entire year. Yeah. I have been running one EC2 instance for the last 8 months just for me to play on, and it's running 24 hours a day, 7 days a week. And I have paid, I think I started it originally as a large machine instance, so I owed them $2. I caught it after an hour, I'm like, uh-oh, or like a couple of hours, I ran it overnight or something. I'm like, oh, that's a large machine instance, but it has more firepower, so I owed them like $2 or something. But then once I turned it into a micro instance is what they call it, that's been running ever since, and I haven't paid them anything. You can do that with RDS, with EC2. Basically, almost all of their services that they offer have a free tier. So they say you can do this for this amount of time, and we won't bill you for the first year. And it's really to get people hooked, because then once you're actually running a machine, then you're like, okay, well, now I got all my stuff hosted here. I don't want to. So come January, I'll start paying them. It's like $10 a month, or $15 a month, or something. So to start this, I'll just grab the stock Amazon Linux AMI, which is a 64-bit machine, and I'll hit select. And these are the machine sizes. What the machine sizes are, it determines how many CPUs and how much memory the machine has, basically. Mm-hmm. So the micro machines are free tier, which means you're allowed to use those and you're not going to get billed. Most of the ones that we use at work are the medium or large, because we need more CPUs and more memory available. But for this, we're just going to go with T2 Micro, free tier, which means it has 1 CPU and it has 1 gig of RAM. And there's several screens to walk through. Most of the time you just zip through all these screens, you don't really need to customize anything. And if I have time, we can go back through and look at all these options. This is just network configuration. You can leave all that default, what network interface. This is the storage, just saying, okay, how much space do you want on the machine that we're going to start up for you? Or I can add another volume. So if I want a second drive with like 100 gigs of storage for like a database or photos or whatever it is, I can add a new volume here. These are basically a security group that dictates who can get to your machine, and this would take a whole session itself. Basically, you can say, this one that I create, default Linux HTTP, when I created my other machine, this It allows SSH from my machine, so I can remote to it to do things. And then HTTP, port 80 on the entire world can get to it. So that's the default one I created, and they have that like out of the gate. And I'll do review and launch, and you just review everything that you told it. There's my, from my IP, which I don't know if that's actually my IP. We'll find out here in a second. And we'll go ahead and launch the instance. Now it's going to say, which key pair do you want to use? I'm going to say Beer Hipster, which is the one I showed you before. So now it's going to go ahead and launch the machine. So now we're spinning up a new machine in Amazon. And we'll go back here and we'll actually see it say pending right there. So right now it's starting up that machine. We have all sorts of details here at the bottom. And this takes about a minute. What we are going to do, some of this is it gets a little bit technical. The way these there's these things called elastic IPs. Elastic IPs, Amazon will give you an IP that doesn't change, which is what you need to point a domain to it.
Right.
So this was associated with that other machine. Let me turn off that other machine I was using if I didn't already stop it.
I think you did.
I did stop it, okay. So what I'm going to do is, I need that elastic IP. They charge you per IP, so I'm not going to create a new one. This one that I had pointed to the other machine, I'm going to disassociate it from that machine. And I'm going to say, okay, this one, I want to associate with the new machine, which you just start typing WordPress custom setup. And I'll associate that IP with that. So now what I've done is, I already had that set up in my DNS hosting. I already have that IP entered, so I don't have to make any changes in DNS. There's that machine. So now you can see if I do service HTTP stop, and we refresh this,
Right.
I just turned off that. So now we have that web server running. So
But I thought you pushed the other domain to that, didn't you? The beer.
that's no full-fx.
I
use the IP that full-fx was using.
I see.
Yeah. Yeah. So now what I'll do is install PHP and the PHP MySQL driver you need for PHP to communicate with the database. So that's PHP and PHP-MySQL. Yes, install it. So now both the PHP and the driver is installed.
And that gives you the latest PHP?
Mm-hmm. Yep, that will be whatever the latest stable version is. And we have to restart the web server since we just installed PHP. And now what we'll do is we'll install MySQL, an actual MySQL server. So now this is going in, it's setting up MySQL with couple of test databases. Now we'll tell MySQL to create a database called blog. Oh, I have to start MySQL. All right, there it goes. We'll create blog, and they include for MySQL, they include this tool called secure installation. Because by default, when you install MySQL, the root password is blank, which if somebody was able to connect to this right now, they would have full access to our database. So this tool that they include, you just run as MySQL secure installation. It'll say enter the current root password. Yes, I want to set the root password, and I'll just call it AWS 2014. AWS 2014, which probably still isn't a good password, but regardless. Remove the anonymous users from the database, disallow remote login, remove the test database, reload the privileges. So now that just secured MySQL and made sure nobody can get to it except for us. Now we'll go, all those pages, everything that's hosted on this web server is under this directory, var www html by default. And if you start a different machine image, it'll have it in a different location. Most of the time on Linux, that's the location of where everything web related. WordPress.org, and they have in the root, they have latest, a zip package basically of the latest installation. We're downloading that, and we will unzip that package now. And now we'll have a WordPress folder, and we'll move that to blog. So now we have a subfolder called blog under our web root that has a WordPress installation in it. So now what we have to do is, let's go to the blog directory and we'll move, they include this config sample. You have to just rename that to WordPress config, and then we'll edit that to put in our database details. So right here, that's the database name, we called it blog. And then this is the username, we named it, it's just root, which is the default. The password, which we made AWS 2014, and the database is on localhost. If you were using RDS, so you had a database hosted elsewhere, you would come into this config and Amazon would give you a DNS name of where that database is. You would put that instead of localhost, and that would connect to a remote RDS instance. So now we edited the config. Now we go, so this is the root. If we go /blog, now it says, okay, go ahead and set up your blog. So we'll, blog in 10 minutes. And the username, let's WP admin, password, I'll just make it webmaster at full. And don't go on the index. Install WordPress, and now we have the WordPress site. Mm-hmm. So that was about 10-15 minutes. We had a whole site set up, even though it's easy. So we're gonna, there's different things you do here with the machines. There's a stop, which just stops the machine, and then there's terminate. Terminate means delete the machine, delete the volume. What I'm gonna do is that machine that we just created, we will log out. Log out. So now we're disconnected from the machine. I'm going to terminate it. We don't want to release the Elastic IP. I'm going to terminate it. So now if we reload this, whoops, now this is not resolving now. So now my machine has just been destroyed. Mm-hmm. So there's an even easier way of setting up these machines rather than running all those commands and sending all these permissions, because that takes a couple minutes, and it's a little bit hard if you're not technically inclined. So what happens here is Amazon has another service that's called CloudFormation. CloudFormation is a way that you can have a script that you say everything that I just did here with all these actions, run MySQL secure installation, install MySQL, install web server. You can put in a script, feed it to a CloudFormation stack, they call it, and Amazon will start as many machines as you have configured in that stack, run all those commands on the machines, and then give that whole stack spin up. So if you wanted to start 20 machines that are extra large instances, and once they start, they're going to go to Google and do a search, you can create a CloudFormation script like that. It'll start 20 machines, run that, and then shut down all 20 machines if you want.
And did that exist 2 years ago?
CloudFormation, I'm not sure how long they've had it, and I think it's fairly recent they added that. They have had the Elastic Load Balancer for longer than that, but that's really for web front ends. CloudFormation allows you to automate creating a whole stack of machines in AWS, which is pretty powerful. So a lot of people use this if they have a lot of data to crunch. They may use CloudFormation to start 10 Hadoop clusters, process all this data, dump it into a folder, and then shut down all 20 of those Hadoop clusters. So a lot of people use that for automating processing large data sets or things like that. I have this guy that did a web crawler. It's kind of an interesting read, and I have it in a link. We talked briefly about it. He did something similar, but he manually spun them up, but he had a whole cluster he started. So now that machine has been terminated. Now what Amazon does is, it says terminated, it's like an hour or two. They have some sort of cleanup thing that comes around, and it'll remove it from here and it'll disappear. It seems like it takes 2 hours, 3 hours or something. They have some sort of cleanup policy. So now what I'll do is I actually have on here another, this is an example of a CloudFormation script. It's a little bit in depth and it's hard to read. This is JSON, so all I'm going to do is I'm going to copy that. And actually, I don't even have to copy that. All I have to do is see how this is hosted in S3.
Yeah.
I just have to copy the URL. It's even easier. And then what I'm going to do is...
So that's an existing template though?
Yeah. This is a template that somebody, that Amazon actually created. And this is a WordPress single instance template.
Right.
So what I'll do is I'll come back to services. I will go to CloudFormation. And I'm going to say create a new stack. I'm going to say WordPress single. No, WordPress single instance. And I have this link to that script in the slides. And here where it says where are you getting the script from,
Right.
Amazon S3 template URL. I'll hit next. This is, and now it prompts me for the variables basically that I put in. What do you want your database to be called? WordPress. What do you want the DB password to be? I think it says it in the script, but I don't care what it is. The root password, I'm just going to say AWS 2014. The username, the instance type. If you're using CloudFormation, you cannot start a micro instance. You have to, at the smallest one you can do is an M1 small. So you're going to be charged for this.
Mm-hmm.
They don't allow you to do micro instances because if you're using this, they want you in the larger tiers. The key name, my key name is just Beer Hipster. That's what it's going to use. And the SSH 0000 means anywhere. And I'm going to hit next. That's an optional key if you want to name it. I'll just skip that. And it's just saying, warning, this template creates instances, you will be charged for this. And so, okay, yeah, great. And now this takes a little bit longer, but basically what this is doing right here, this creating process is doing all of these steps that I just did there, automatic. Now this is actually installing an older WordPress version, I believe. Either older or new, I don't use WordPress that often. But this is a different version, there's probably an updated template somewhere. And then you can watch your stack being created. Like if you have 10 machines, it'll create events here of machine 1 created, machine 2, machine 3. While that's going, let's see, that was the first kind of demo I had.
That was great, John.
Yeah, it shows how easy it is to start machines in this. And if you're using the free tier, it doesn't cost anything. I've been playing with this for a couple months, probably 6-7 months, and like I said, I got charged 50 cents for the Route 53, and I started a large instance by accident, which cost me $2 or something. And you can play with all these services for free. It doesn't cost a dime.
I've been on projects where there's been like inconsistency in the configuration and the different instances, and so it's a little, I'm drawing on that and realizing that we were manually, like we were adding instances as we got further into the project, and we weren't using any, it was all done manually.
Right.
And so these are where, I mean, it wound up really being a big problem. And I just don't, so that's why this gets born, this CloudFormation out of those? Yeah, that's fine.
Like CloudFormation, we didn't directly use CloudFormation because we haven't written those scripts. So there's so many different ways you can actually start things in an automated fashion. And there's a couple more events. So it'll create a security group. It'll assign this security group. There's also something that Amazon calls user data scripts. So if we go to EC2 services, or EC2, there's also this knowledge, this concept, and here's actually the one that's running right now. So that's my machine from the CloudFormation script. So it's initializing, and when it's fully complete, it'll be startup. It's still initializing. If you launch an instance, when you get to a certain step here, configure instance details, advanced details, they have this user data. This, if you're starting up a Windows machine, this can be a PowerShell script. So PowerShell, just like with Macs, you have the command line where you can run commands and run shell scripts. PowerShell is the same thing for Windows. So in this user data section, it will run this script one time when the instance starts up. So if I wanted to, I could have created a bash script that ran all these commands, pasted it right in this user data, and would have done the same thing. We use the user data for running PowerShell scripts on first startup of the machines if we have specific things we need to do to the machine, and we only need to do it that one time when the instance gets created. So that's one way that you can automate configuration. The CloudFormation is not, I think this one's more of an example of what you can use it for, but CloudFormation seems to be, okay, I am setting up, my friend Mike, he works for an ad agency and they set up a bunch of WordPress sites. A client will come in, they'll start up a MySQL instance, a WordPress installation, and they'll connect that and dump the SSH keys, connect the SSH keys so they can talk to it. I'm not sure if they're using AWS, but that would be a good example of a CloudFormation script. Just talking about that's user data, and that's the script that they have there, which is basically the same thing I did here. Install HTTP. What does it do? It looks like it does some security stuff within the WordPress config, or creates a WordPress config, and it sets up everything for you. The only thing that stinks is now, since I just set this up, this DNS name here, this EC2, and this is the IP address, .compute1.amazonaws.com. If I stop this machine and restart it, that changes every time. So now, since I set up this WordPress blog where it said, oh, this is the domain that it's going to use, when I start up next time, the style sheets won't load because it's looking for that URL, which no longer exists. So that's why if you start up a blog like this on an EC2 instance, you want to point your domain to it first and then do that initial setup from your domain name.
Right.
Otherwise, you'll have to go into the config or into the control panel of WordPress and change the root URL and where to find all of the style sheets and things like that. I found it's just easier to point it to your domain first and then use that URL when you're actually setting it up. And then what we should be able to do now, since I told you to use Beer Hipster, is if I copied this, now I should be able to SSH to that. Yes, connect. So there we go. Now this is a machine that just started up from the CloudFormation. So now, once the CloudFormation script is done, it's okay. The CloudFormation script is completed. So now I'm just going to terminate that instance. You actually see it just popped up there and said, "Oh, machine's going to power off," and it booted me off because I turned the machine off. Now we can terminate that. Now there shouldn't be anything under CloudFormation since it's complete. Or I actually have to delete the stack. I said yes, delete it. And then what it would do, it'll probably just going to throw an error now. I didn't have to terminate the EC2 instance. When I deleted the stack, it would have deleted the EC2 instance for me. Basically undoes all the resources that I just created. So that's quick, straightforward how to use CloudFormation. So now if, you see, these are all of the services they actually offer, and there's a lot of them. We can go through a couple of them really quick, at least the ones that I've used before. EC2 is a virtual server, as we just saw. Route 53 is a DNS. This I actually have 2 domains set up, so we'll go here and 2 hosted zones. You see beerhipster.com and fulleffects.com, and then if you go and edit that domain, this is basically all the DNS information, and here's my A record. So if I create a new Elastic IP, I would come over and enter it in there, and then everything www.full-fx.com will then be routed to that IP. You need to provision an Elastic IP because otherwise every time you start and stop a machine, it's going to get a new IP address. Once you associate an Elastic IP with it, that IP is pinned to that machine and will never change, which you need for the DNS to work correctly. So, actually I should point, I don't think I have anything set up on FullFX anyway, so that's Route 53, and you can go back to hosted zones. There's the other one I have, Beer Hipster. You go to record sets, and you can see the zones that I have here, which is just www, and that's another Elastic IP that I have that I provisioned.
Where do you do your emails and stuff?
So Amazon has a service for that.
So, okay.
They have a service here. It's simple.
So, but you don't do it there. You can't create an MX record there, right? You have to go do it elsewhere. And then
if you start an EC2 instance and you install something like Qmail or whatever SMTP server you want on that EC2 instance, you could create an MX record there, I believe, and point it to that EC2 machine. But Amazon makes it even easier. They have what they call SES, which is Simple Email Sending Service or something. I haven't played with this.
So this is for broadcasting, you mean?
This is for actually sending emails.
Really?
And Amazon has a dedicated service for that.
Wow.
Now, I think they have some, you can always send email to the Amazon SES mailbox simulator. So probably what they do here, and they do this with a lot of the services, like when we first started, they have a limit of, I want to say, 40 EC2 instances or 30 EC2 instances, and they cap that for any new account. And if you want to use beyond that, then you have to contact them. It's literally like a 30-second process. You email them and they say, okay, now you can use as many as you want.
Right.
They just want to make sure you're not abusing the
Right.
service. It's probably the same with this SES. They want to make sure spammers aren't in here blasting people with emails. So I haven't played with that one though, but this is for sending emails. Max send rate is 1 email per second. So you can probably bump that up.
Yeah.
Learn more about your your sending limits. So they probably cap it until they know. Yeah, you can send 50,000 emails in the previous 24 hours. So it's a lot of email.
So you think there's a cPanel EC2 virtual machine that would like web host manager that would spin up new email accounts?
That's a good question. I haven't
Like
seen.
AMX.
Yeah, like what do you call it? Is it cPanel or there's another?
Yeah,
one?
the Plex or whatever. There's
Parallels?
other. Huh?
Parallels?
Yeah, Plex Parallels or whatever.
I bet you if
I like cPanel personally.
Yeah.
cPanel cluster.
Yeah.
So there is
And
a
web
machine
host
that's-
manager and stuff like that, where you could programmatically generate a new site for someone with their cPanel and
Control panel.
Yeah, I prefer that to Linux too.
Mhm. So they got community images that are that have cPanel already installed. There's a lot in here. I mean, so we use Microsoft SQL Server. The problem is because some of the configuration we're using there, we can't use the ones hosted in RDS, so we have to actually have an EC2 instance with Microsoft SQL Server installed. They have, it's not under the community, it's AWS Marketplace. And on here they have MS SQL. Oh, there's Plesk panel.
Yeah.
Under here, SQL Server. Here's a quick start. Well, somewhere under here they have, Amazon has Windows Server 2008 R2 with SQL Server installed. Those are a little bit more expensive.
I'm sure an IIS instance.
Yeah, and the web servers, with those, they won't give you one pre-configured with IIS, which is a web server for a Windows server. You actually just have to start a Windows Server 2008 R2 and then turn the feature on, and then you can create your own AMI around it. Other services they have in here, EC2 is machines, Route 53 is DNS. VPC is virtual private cloud. This stuff gets a little bit hairy of the configuration in here. Basically, you can create your whole data center within Amazon's data center. By default, whenever you create an account, you have a default, they call it the default VPC, which just has everything open, everything in and out, and you have to control it at the machine level. What happens in the VPC is you have these subnets. So for instance, these subnets here, you can probably tell where they are. This one is, there's the availability zone. This is US East 1B. This is US East 1A, and this is US East 1C. So these are 3 different subnets and 3 different availability zones in one region. So if I wanted to spin up, you know, 2 web servers in one data center and then spin up another 2 web servers that mirrored those, I would choose a different subnet, and that's going to put it in a different availability zone. But this can get, the configuration of this is pretty deep. You can come in and set inbound rules. So this is basically like what you would have with a routing table if you're configuring a router like a Cisco router. You would come in here and say, here's my inbound rules, here's my outbound rules. You can say, hey, anything that's on this subnet can only communicate with this other subnet. And they have something in here called Internet Gateway. This is where all your traffic comes in from the internet. And you can say that this subnet can only communicate with the internet, while these subnets are completely isolated. Nobody can get to them, only you can get to them.
Right.
So we
Or a
leverage,
team or a location. Or
exactly. And then you can connect that gateway. They have, what was it called? Customer gateways. Or no, maybe it was virtual private gateway. Virtual private gateway, what you do there is this you create, and that creates a gateway between your data center and Amazon. So it's basically like a VPN,
VPN, right there.
between
Yeah.
this Amazon VPC and your data center. There's a whole bunch of stipulations that go into configuring this, but that's basically the high level concept. You can create your own private cloud within their cloud.
Right.
So if you were like a retailer and you had an event, like a Black Friday through, like if you had a traffic event, whatever it is, or you're, just for that example. So it's a combination of this configuration in terms of traffic, as well as then like multiple instances, like
Yes.
it's a whole play, and then but you put a time band around it in terms of, because you only want to pay for it for 5 days or for 7 days or.
Yeah, so in those scenarios, that you could probably get away with that without going a full-blown virtual private. There's a lot of
This is really more for like extranet. This
Yeah.
team accesses these areas. This
Yeah.
team accesses that areas only from this location or anywhere. It's like creating that VPN for different.
Right.
Yeah.
But that
So are you
traffic
saying
configuration, though, is a
instead
little-
of
yeah.
buying a piece of hardware to put at the house, to have someone or a vendor or two RDP into it, if I host it out here, I don't have to buy the hardware every 3 or 4 years.
You mean firewall and stuff?
Everything.
Yeah,
If you're going to,
That VPC, you can configure a firewall.
Yeah.
You can set up the routing rules.
right,
You
say an
can-
app server and, right, database, whatever.
What you're referring to, Lisa, is they have, if I can find the launch configuration, it's actually going to be under EC2. Under here, they have auto scaling groups and launch configurations. I don't have any configured, and I didn't have enough time to create one to show you. But basically, what happens here is you have these launch configurations. You can do all this from the command line, but you create a launch configuration. So let's say launch configuration starts with a single machine instance. So let's say you're setting up a Black Friday event, and let's say I already created a machine instance. So for instance, my WordPress blog, I created an AMI out of that. So it's all pre-configured, it's all ready to go. I would create a launch configuration for it. And then what happens is you deploy machines into that launch configuration. So called CloudWatch, which is a monitoring service that they have. And you can say, the example I saw, it says when the average CPU load of the machines that are currently in that launch configuration exceed 80% on average for 3 full minutes, launch 2 new instances. So then what it'll do is it'll take that AMI that you defined, it'll start 2 new machines and start them up. And then every minute that CloudWatch is going to look at all the machines. If it's under heavy load and they're all going under heavy load, and you can give it a max number of machines to launch. The example I had, the guy did 10. And then he used a little tool that just pounded the web server. And you can see it, okay, there's 2, now there's 8, now there's 10. And then he stopped pounding the web server and it went back down to 2 machines. So that's what an auto scaling group does. It'll automatically scale machines according to your load. Now for stuff like we use, we probably wouldn't be using, we could hook up a CloudWatch alarm to monitor what the work it is that we're doing. The work that we do isn't really web-based. It's more CPU bound. So we'll have a chunk of work come in, and we may have, let's say, 2 or 3 worker servers that are processing this work at one time. And we have a certain amount of throughput per machine. So we could hook up a CloudWatch to say, hey, watch these message queues. When the message queues have 5 messages in them for longer than 4 minutes, we're going to violate some service level agreement we have. So triple those to 3 additional machines, and then those machines would start taking on more load, or 10 workers. And then once those message queues get under control, then spin those down and just leave 3 there. So the way that we're configured, we can spread load horizontally over machines.
Programmatically, no one's watching.
No. Yeah, we basically have distributors, and then there, behind the distributor there's X number of workers. Most of them have 10 machines, 15 machines or something like that, and then it'll just do round robin. Every piece of work that comes in just gets round robin to the next server. And that's also what the auto scaling groups will scale up, but then you can use what's called the Elastic Load Balancer, which is another service you can plop on top of that. The Elastic Load Balancer, I think that's under EC2 as well. Load balancers. Load balancers, you create a load balancer, and what the load balancer is it's basically a DNS entry that sits in front of your machines. So what happens is all traffic is routed to that load balancer, and the load balancer, I think it's running Linux or something, It's really fast, and it'll take each request and push it to the next machine in the elastic load balancer. That spreads your traffic horizontally across multiple machines. And then at that point, if you had something like that, let's say you had 6 or 10 web servers that are taking on load, then your database would become the bottleneck, because if you had one database server and all 6 of those running, so then you would
Replicate the data.
replicate the database instance, which you can also do with, I think the Elastic Load Balancer works with EC2, and by default for your load balancer with a standard web server, but you can add whatever port you want here. So you just put in MySQL port and it would balance to that. And then that should replicate properly if you have MySQL replication configured. But this is for the load balancer, so if you're undergoing a lot of traffic, you just add new machines into the load balancer and it'll start spreading traffic across all of them. It's a document store where it's basically a schemaless database, so it's not like MySQL or SQL Server. DynamoDB is Amazon's version of that. So they created their own document database because they want people to use that rather than Mongo. But there's plenty of machine instances here that have MongoDB installed that you can spin up. I think on my other machine instance, I have Mongo installed on there. Elasticache is for in-memory cache. So if you have a lot of records that you can pull from the database often, you can push it to Elasticache and it'll hold that in memory. So the next time somebody asks for that record, it'll just serve it up from memory. So it's very, very fast. The other services in here that I'm trying to think of that are useful, I've seen this one. This one they just released, but I haven't looked at it. Mobile analytics. They have some way now that they can track analytics of your customers that are browsing with mobile devices, and they dig into that somehow and give you analytics of what type of data you're gathering or what your customers are on mobile devices or something. I haven't looked at it, but that was probably a month or two ago that came out. It's new. As an example of the Elastic MapReduce, I'm not going to run a cluster here, but I ran one, I think it was yesterday, in my S3 buckets here. I started a Hadoop cluster, and I just used their example, and I told it to push the output to an S3 bucket. So right here under word count, as output is yesterday's date. You can see here, just dumped a bunch of files in. If I download that file, and let's open that up. This is what MapReduce ran for me. So this word, Abel, occurred 9 times in the data set of books that I fed into MapReduce. So this is just this is their sample. It's just a simple, I like the one, A occurred 14,716 times. So this was a data set that was fed into Elastic MapReduce. It ran a function to say count this word and then dump it into this output file. And it's a simple example, but you can get an idea of how that would run for running analytics or building different data sets on, oops. So that's an example of Elastic MapReduce. That one's used very often. You hear a lot of people talk about it. And that uses something called Hadoop on the back end, which is an open source framework. And then these are application servers. I haven't really messed with any of these. There's the email service, the message queuing service. Microsoft has something built in called Microsoft Message Queuing. This is the same thing except Amazon hosts it. And that's really for scaling workloads and things like that. And that's what we use it for at ACI or MSMQ. But it's the same thing that they have hosted here. They have a workflow service. I'm not sure what's in that, but I glanced at it briefly. For doing searches on Reddit, when you search for a Reddit article, they use this cloud search. So they're digging through some database and they use cloud search to do searches on real time. So real quickly, so that's kind of the high level there. The next thing here was, and you can't see it here. I said, okay, that's great, but how much is this? Because it can get a little bit expensive very quickly. So what Amazon has produced here is they have something called the AWS calculator. And you can use this calculator to determine what it's going to cost you to run what it is you need to run. And this is, you can just search for it online, and it's just called the AWS calculator. So for instance, let's say on that machine I just ran over here on EC2, or this one that I am running for one of the domains I was hosting there. This one is a T2 micro. I think for the volumes, on that one I just have one volume, and it's an 8 gig solid state drive. So I will punch that in. I'll add a row. This is website one instance, 100% utilized. So you put in what your utilization for the month is. If you're only going to run half the month, you put 50%. If you're going to run it the full month, you put 100%. So a web server you would commonly have on all the time. And then mine was a T2 micro. And on demand, I'll explain that in a second. And now the EBS volume, I had one volume. It's solid state. It's 8 gigabytes. And now what we'll do is, so that covers that one site I was hosting on that machine. You go to the bill, and you'll see here, you can dig into it and see what they're actually charging you for it. So now, since I'm still in the free tier, they make a discount called free tier discount. They subtract it because I was in the free tier with those services. But normally, just running that one machine with 1 gig of RAM, 1 CPU, and an 8 gig drive is going to cost me $10 a month. If you had something larger, like let's say we had that, and then let's add S3. Let's say we had 50 gigabytes of stuff stored in S3 for the month. And then let's say get requests. So that means that I'm pulling something out of the bucket. Let's say we had 1,000 of those in the month, and we updated 500 times or something. Sometimes it's hard to determine how much you're going to use here. Data transfer in, let's call it 5 gigabytes, and data transfer out we'll call 10 gigabytes. And so in the free tier, that would have cost me S3 services for doing all that, for storing 50 gigs in 1 month. It would have cost me $1.50, $1.52. You can see like most of this stuff is pretty inexpensive, so you can store a lot of data in there for pretty cheap. And if you ever use Carbonite or Backblaze or any of those backup services, all those backup services use S3. Most of them do, I should say. So they just give you a client to back this up, but behind the scenes they're just storing all that in S3. And then they figure out the most efficient way to combine that with other customers, and they're charging you probably $15 a month, and it's costing them $1.50 for you per month. So that's how they make their money.
I mean, there's such storage wars going on right now.
Oh, it's all
between Microsoft and Google. You
Apple, everybody's got
know,
yeah, you got iCloud. Now they probably store that on their own infrastructure.
They all increased it. Like Microsoft increased it to 1 terabyte per user per seat, and I think Google is like some ridiculous free amount also. Google Drive.
And now Flickr made
Flickr made it
1
free.
terabyte.
Yeah,
1 terabyte of photo storage, which is a crazy amount of photos, and that includes video and everything. Yeah, storage is cheap, but services like this still. I mean, that's not too bad. $1.52 for the whole month for storage, so it's not like it's a lot of money. It's essentially like an offsite backup that you have. And then you can go through all the different services here on the left. So they have all their services down the left, and you can quickly see, hey, what happens if I use, this is a relational data instance. So if I had MySQL on a small, how much is that? That's where it shoots up there. So that would have cost me, RDS service, that would have cost me $40 to host that database in RDS. So it'd been cheaper just to have my own EC2 instance and install MySQL on there. If I use the RDS instance, that's where it gets a little bit expensive.
Why is that? What do you think?
That's a good question. So I may have had multiple instances here or something. One instance, 100% utilized, probably because it's a small. If I did like a T2 micro, which is much smaller, which is 20 gigabytes of storage, it's just less firepower, that drops it to RDS $12. And then some of that's covered by the free usage tier, because they give you, I think it's up to 10 gigabytes of free RDS usage in the free tier. To quickly talk about sizes, or our pricing around these services, you've noticed here when you look at RDS, there's all these different sizes here. There's T2 micro, T2 medium, M3, R3, M1, M2. They slice their instance sizes a million different ways from Sunday, and that usually deals with resources, how much firepower that particular service is going to have. So even the EC2 instance at micro, that's 1 gig of RAM, 1 CPU. If you do something medium or large, if you do, pricing, they have tables that they show you what all the prices are. And this stuff, I mean, if you're not careful, you're not watching it, it can add up quickly, but it does make your head spin when you look at it. Here's the free tier. So this is basically saying 750 hours of an EC2 instance per month, which is a full 31 days of running an instance. This is what they give you for free. They give you 750 hours of running a Microsoft Windows server. They give you a month of elastic load balancing, 30 gigs of EBS, which means your volumes. You can have up to 30 gigs, 15 gigs of bandwidth out across all the services, and then 1 gigabyte of regional data transfer. It means if you're transferring data between regions, so like east to west or something like that. And here's all the pricing. So if you're saying, okay, here's the EC2 instances, this is for Linux. You'll notice, like for the micro, it's 1 cent, almost 1.5 cents per hour to run a micro Linux instance. Now if you look at the Windows, Windows is almost 2 cents an hour. And that has to do with the licensing. They have to pay Microsoft for the licenses, so those are going to be more expensive. 113,669 pages for $580 in 39 hours. He had one master, which was his machine, and he spun up 20 extra large instances in EC2. And he created a Python script that took, there's a public data set, Alexa top 1 million. When Alexa went out, they released the top 1 million web pages on the internet. He used that data set and he sectioned them off to these 20 instances and then told them to go crawl these websites, and he crawled that many pages. Originally he said he was going to release a code under open source, but he realized that it could be used very maliciously, because then somebody could spin this up and do a denial of service attack against a website very easily. But this is an interesting read of how he did the threading and how he figured out what the highest optimized, the best configuration. He figured out that 141 threads per machine was the most optimal configuration for the price. And he also talked about something here that I didn't go into, but there's something that Amazon calls, he did $580 for an on-demand instance. There's these things when you create an instance, there's on-demand or a spot instance. What a spot instance is, if I go to create this and I say, okay, request spot instances. What a spot instance is what Amazon does is very smart. An on-demand instance means when you start up the machine, all that CPU and all that memory is dedicated to you. Nobody else is allowed to use that. That's your CPU, your memory. You pay a higher price for that. A spot instance states that, okay, when my CPU and my memory isn't in use, they take that CPU and memory and they use it on other spot instances. So when your machine is dormant, they're reusing those CPU cycles so they're not lost. As a benefit of doing that, they give you a drastic discount on the price per hour if you're allowing them to recycle your CPU.
Right.
So that's what a spot instance states. This guy said that he determined if he would have done spot instances, it would have been like a third of the price. He would have done it for under $200 or $250 or something.
Would it though? Because he'd still be using it though. Oh no, the unit price goes down.
Yes.
Yeah.
And then they have another thing that you can do that is, they call it, I forget what it's called. It's they have another way that you can pay for each. You can pay for the hours up front for an entire year. Mm-hmm. Where do they? It's somewhere in here. That one was light utilization reserved instances. So reserved instances, what you do with reserved instances, you pay a reserved. I forget where the thing is here for EC2, but there's a reserved instance you can on demand. There it is. So you can say 1 year light, like 1 year medium reserved. It takes the price from almost 1.5 cents per hour down to 0.6 of a cent per hour. So it reduces it by over half.
Yeah.
The price. The catch is for a 3-year cost, you have to pay $284 up front, and you're basically paying half the price. So if you know you're going to run a machine for the entire year or 3 years, you buy into that reserved instances, and then, oh, thank you, you're going to get a drastic discount on your instances. That's different than the spot instances. The spot instances are saying, we're going to reuse your CPU cycles. So, and you can go on and on with the services that they provide, but those are most of the large ones. And here's where I had, and I'll pass this along to you, Kai. And this is all of a couple of links that I spoke to. The calculator. There's a CloudFormation template that you can use to spin up an instance. The steps that I had there, I just followed some guy's blog and made sure all the steps worked, and it was pretty straightforward.
Let me ask you this. Now, why would you host a website here, like a regular website, whether it's Joomla, whether it's...
What's the advantage you get
yeah,
out of it?
what is the... Because not necessarily there's a price advantage. Unless... Well, no, not really, because you're creating different instances for each website. Anyway.
Yeah, there's actually not now. There is a price cost savings in the fact that, like, for instance, this domain right here, the beer hipster that I had set up here. Originally, I had full effects pointed to the same machine, so I think it's set up in there. I stopped the instance like a week ago, but what I did was I set up. It's called Nginx, which is a web proxy. So what I did was I can install multiple websites on that one instance, and then with that proxy, depending if they're coming to Beer Hipster, I can route it to one folder or another folder. And I was hosting that using it's called the JavaScript framework Node.js, which is a server-side based JavaScript framework. That's like for hosting that website, that's the benefit I get out of it. One, I want to play with a new framework that I haven't played with before. Finding a web host that has Node.js installed is very difficult because it has to be installed in a specific manner. There is lots of web hosts out there, but when you actually look at the pricing, when I looked at the pricing of running Node.js, there was a Node host or something that hosts it. They actually charge $15 a month. Where this instance I can host multiple sites on, all running Node, cost me $10 or $12 a month. Right. So I save $3 a month. In addition to that, when I start up that machine, I can remote into it, and I have full access to install whatever I need. I'm the only one on that machine. I know all those resources are dedicated to me. If you go with a shared host, then your resources are being shared.
Limited, yeah.
But if you're not doing something specialized like that, like I was trying to set up on there just to configure it and play with it and see what its strengths were, then you could go with a off-the-shelf, shared host, and it is going to actually be more inexpensive than hosting it here. I would say that these are kind of labeled as premium prices because you are getting a full-blown server that's dedicated to you. Nobody else is on it. Nobody else is touching it, to the point where Amazon doesn't even install patches for you. That's your responsibility. They do nothing. So it is a little bit more expensive. Some of the other services they have in here make it easier as that website if you have to scale it, or it makes it much easier to do that. So that's kind of the main thing I would say. It is definitely a premium price, though. It's not cheaper than shared hosts and things like that. The other statistic I have of this guy that did the crawler, in 39 hours he gathered 2 terabytes of data, and yeah, it cost him almost $600. And that was that. And so now we kind of aimed off just about on time. If we'll start that one up while we're sitting here. Do you have any questions? Or I've been trying to stop one instance and start the other. Otherwise, if I'm running 2 instances, if I run that one instance for a month and I start another one up, then I'm out of the free tier because I've gone over the 750 hours per month. So Not that it costs a lot, it's just then I'll have the wife say, why are we getting billed $20 a month for it? When I first started, by accident, I didn't check the instance type, and it was like a large instance, like I stated, and it was just a couple hours, it was overnight or something. I'm like, oh, whoops. The last thing I wanted to show, I forgot to show this is really good. I found somebody saying that they did this, and I did it as well. CloudWatch is alarms that you can set up on the machines, but you can also set up alarms around billing. So what is in here is a billing alarm, and this, they have a metric called estimated charges. So I set up an alarm, a CloudWatch alarm, that if estimated charges go over 0, it will notify me via email. So it'll send me an email, and actually that first day, that's how I found out about it, when I was running that large instance and I didn't shut it off. I got an email and I woke up in the morning, I'm like, what's this? I owe them $2. I'm like, oh, let me look, and this CloudWatch alarm alerted me, said, hey, you just went out of the free tier. So these are alarms that you can set. So if you can say, I don't know what these ones are, ones that they automatically, it's metrics around disk writes and reads on that. But you can set up these various alarms. So here you go. So it does data transfer, EC2, Route 53, S3. It does most of their services, and tells me where the estimated charges are over 0, which they should be at 0 on in the free tier. You can have it send you an email. You can have it use SES to send an email, which I believe is how they send these emails in here, is using their own service. But that's useful to do, and you can set up an alarm if you are going to use the free services, because it's easy. Once you have an account and they attach it to your Amazon account, which most people already have an Amazon account, you can just tie your AWS stuff to your Amazon account, and they'll conveniently just use that credit card that you have tied with that to bill you for this. They don't tell you, hey, you just got billed. It's your responsibility to watch and make sure. And I've heard of people go in here and by accident say, oh, whoops, I owe them $200 because I started 10 machines that I left on for a day.
Yeah.
You know, so they won't let you know. And that's about it. So if you have an operating system drive that started with an instance, they say don't put anything on that drive, but as long as you have that machine, that drive will pertain. But if you want to store something attached to that server, you should create an additional volume and then attach that volume to that machine. Okay. Like for instance, this one is.
Why would you have the Office up there, though, Robert?
Well, I mean, in one of our use cases, and I don't know too much about it because I don't use it, but we were using, I want to say, it was Microsoft Access. Yeah. And okay. I think once they powered it down or shut it off or something, started back up, and it was not there. So none of it persisted. So.
Yeah. So they will. I found that on the Linux instances, everything stays configured, but I think if you place files on there, when you shut down the machine and start up, they wipe. They say don't put anything on that main drive.
But Access is an exception. If that's why you're asking, you can do an Access installation, I'm pretty sure. Yeah, without provide, because it's like SQL, you know?
Right.
Yes.
You can power websites with Access.
Yes. Now the actual Access, that volume will persist no matter what. And when the machine starts up, it'll be present there.
Right.
So they can use their Access on there instead of converting everything to SQL? Or is it better now to just convert to SQL?
Well, if you have multiple users using an Access database, there'll be a performance drain on it. So if you're actually storing a lot of data or you're having multiple users hit it, you should use Microsoft SQL Server or MySQL.
Actually, I have.
But you could use you can have multiple people go into an Access database.
I still have an Access database for a website that has simultaneously maybe more than 15 users, sometimes 20 users, and that has 14,000 unique visits monthly. Mm-hmm. It's very scary, but it's holding up. You know, it's like.
No, but because I have a client who has this really huge Access database, and it's on 2 servers in his office right now. And all the girls do is they update everything on the server, you know, on the machines during the day, and then he pushes a button and it goes up to the server.
I see.
And their clients can actually go on at nighttime
I see.
and look at the stuff.
Yeah.
But the hosting companies that they're using for the website and stuff is all legacy, so now we have to move everything.
I see, because they're upgrading their operating
Right,
system.
and they're telling him there's nothing he can do, and I'm saying, yes, there is stuff. But I know he's talking to the salespeople and not the programmers, so it's a big difference. So we're trying to now decide.
Where
so
to host that.
I've been playing with, you know, for the last
SQL.
couple of weeks. Yeah, because I know how to use SQL as well. So whether we convert it all to SQL.
And export it. Yeah. In that case, if they have custom interfaces built in Access for editing the data, or they're just editing on the row level. They do have custom interfaces. So that's the only part that you would have to recreate those screens.
The only ones that are touching the data are the girls in the office.
Okay,
Nobody
so it's
else.
But are they using a user interface in touching? There is like actual.
Or they using Access
they can
itself?
only they go into the Access database and they can pull up their reports, but that's all the customers can do.
But when the users in the office, when entering the data, are they going into the raw database, or do they have a user interface that's generated from Access, like a software?
That I don't know, because I haven't
probably
actually
do.
sat and watched the whole thing yet.
Yeah.
But this is what he's been trying for a while now to decide which way to go. And like you said, everybody he's talked to said it can't be done, and it's very expensive if they do it. And I'm telling him, yes, you can, because I have done it in the past.
Yeah.
So.
And you would have to export the data to like a SQL Server instance, but then you'd have to rebuild all those screens that edit the data.
Yeah.
I worked at one place in South Daytona, and the guy there didn't have SQL Server installed. So originally he started with an Access database, and when I first got there, he said, okay, I want you to take this Access database, and we're going to move to, I want to move to something web-based. So it's for all our campaigns. It was a telemarketing company. And I said, okay, what's the database called? And he's like, it's written in Access. It's called Big Kahuna. I said, okay, that's not a good sign that it's called Big Kahuna. And on a nightly basis, we had to run a repair and compact, because on a daily basis it would go over a gig, and then once it reached that level, it would lock up, and then it would corrupt. And he had all these ways for copying a local database, which would copy it locally, and they would edit there, and they would push that back up to. It was a nightmare.
I know this is going to take a long time to do this.
Yeah, that's much easier. You only have a couple people in there.
He's got a ton of records out there, a ton of tables, and
yeah.
He gave me 2 sample files to play with, and both of them are almost a gig age.
Oh my goodness.
So.
Oh, I feel your pain. I'm so sorry. The Big Kahuna one had 720 something tables, and I told him, I said, scrap it and start over. Just don't even bother. I think I started to head him in the right direction, and then at that point, they actually started to run out of money. And another guy that worked there, he was here the last time, Todd, he worked with me there. Eventually, they got them off of Access and onto something. I think it took several years, so. But.
Right, and we have to do a whole new website, because he's still on front.
Well, now you know how to set up WordPress in 5 minutes.
Yeah, but he doesn't want front page. I mean,
Or
he doesn't want WordPress.
So make it look like front page and tell him it's for me.
No, because I actually program in both. I've done front page, and I've converted a lot of stuff into Joomla and the old Joomla, and then into WordPress.
Okay.
So I've done them all. So I think for what he wants, the Joomla is the best.
Would work, yeah.
Yeah.
Anything.
And the new Joomla actually is all mobile ready as well, which is good for what he can use.
Which one?
The new Joomla
Okay.
is all mobile ready also
okay.
automatically.
Like responsive.
Yeah, and so which will be good for him to bring him totally up to date, and his customers can just on their cell phones do the app and stuff.
Yeah, at that point, it'd probably be even easier to take the Access database, export it to MySQL.
Well, that's what I'm thinking of doing.
Yeah.
I think that would be the best.
If you want to get
But
really
I can play
tricky,
with it on this though,
Yeah.
on the AWS.
Yep, for free. So if you go in there, you create an account on AWS, and then you would go to EC2 instances and launch instance. And then when you get here, you would search for community AMIs and just search for Joomla 3.0.
Okay.
You may have to poke at it and play with it, but this would get you started. Bitnami, there's
Well,
a
it's better
Bitnami.
than screaming at Microsoft for the last 3 days, so. Trying to get Access version, trial version.
Now these ones will actually, these community AMIs, I believe, are outside of the free tier.
Okay.
So you would pay for them, but if it's, when you select it and you tell it what size, if Oh no, actually you can start them in T2. Sometimes, see this one only, see how the other ones are blocked out? This one, these community AMIs, they'll only let you start certain sized machines. But thankfully they have T1 micro on, and that's free tier, so you can start it in the free tier. But you can see they have T2 micro turned off and all these other ones.
I don't need to put a whole bunch of stuff out there just to do a demo for him.
On this one, I run this one as micro. This one I have here, this is T2 micro, and I mean, I watch the resources that I'm having people hit it, and it's never gotten saturated with traffic or anything like that.
Well, nobody's going to it.
Nobody's going to it, really. I see crawlers come through every now and then.
Yeah.
But, I mean, I've sat and pounded on a little bit because I'm running JavaScript on the server here and then JavaScript on the client. And it's pretty efficient. Node has a couple little problems there. And this is actually also running Mongo. You can see all the Mongo daemons running there. So I'm running Mongo, Node on this server. And this is, what's the CPU? It doesn't say. Yeah, in HTOP, I don't know how to show the total amount of memory. I think it's like gig of memory in one CPU.
Very good.
Yeah. And I think, yeah, you can, so there's my drives. I only have one drive on here, root. That's XVDA1. If I went here, I went to that, I created a new volume. That's machine ID 822. This is kind of interesting because it comes out and it'll create a volume. We'll just do magnetic. We'll call it 10 gigs. And yes, create it. And then we will, you have to wait until it creates it. And all these resources do take a little bit of time now and then. What's really interesting that I started to see is all of their IDs, they all start with what type of service it is. So volumes are VOL. Instances start with I. AMIs, I don't have any here, but they start with a different prefix. However Amazon is using these, they put them all in one big pool and then they use the prefixes to determine what type of resource it is. Available, so then you can go attach volume. Whichever running one. Oh, you have to actually stop the instance. I didn't think you had to stop it. Oh well. Delete. But then the next time you'd start it up, you'd see it show up here under the drives that are available. Anyways, I didn't show Windows. All the instances we start our work are all Windows instances because we used IIS and C# and all Windows services. So right now we're not running any Linux instances at work, but I do it here because it's cheaper. In my opinion, they're easier to use for setting up something quick. But at work we use all Windows Server 2012, Windows Server 2008 that we started here. And we got all those pretty much automated, joining domains and doing all the various setup we need per machine. We even have a deployment infrastructure, so when we set up a machine and we deploy it off of our AMI, it will automatically communicate back to our data center and register it in our deployment infrastructure. When it does that, then our deployment infrastructure pushes the latest version of a package to it. So right when we start the AMI, it pulls the latest version of whatever endpoint that is, and it starts it up, and if it's configured as a worker, it'll automatically start picking up work right when we start it. So we had to do custom configuration on our end to get scaling working properly. So we didn't use a lot of the things that are available in AWS. It was on us because there was a lot of custom config we needed, but we got it to the point where it's pretty much run a script and hit a button, and we don't even come to this interface. We just run a command line tool and say, give me 2 workers for this type of service, go. And it runs everything automated from that point. We just use all PowerShell.